Okay, what we're going to be looking at here is quadratic equations in standard form. So quadratic equations, which we did look at previous, look like this. F of x equals a times x squared plus bx plus c. Now that is general form, and general form is not particularly useful. So what we're going to do is look at, well, what if we rework this equation and we rewrote it in a form that looks like this. Some number times x minus a number all squared plus another number, which we'll call k. Now this is standard form. Standard form is a lot more useful when it comes to graphing. So what we're going to do is we're going to look at the sort of basic quadratic graph. And the basic graph is y equals x squared, where there's been no shifting or changes at all. It's kind of our home base graph. And what I'm going to do is get a few points in a table of values. And you really want to get to know this graph, basically memorize it, and work from this basic graph. So we're going to plug in some numbers for x. This should be more than enough numbers, and I'm just going to take those numbers and square them, giving me the corresponding y values. So negative 2 squared becomes positive 4, negative 1 squared becomes 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. So what does our basic graph look like? Well, let me just give you an idea. It's going to have the quadratic parabola shape. And if we plot these points, the vertex is going to be at 0, 0. Then we've got the point 1, 1. And when we go 2 to the right, we go up 4. Okay, so this gives us sort of the fundamental shape of this parabola. Okay, whoops. Let's redo that one and go through the points a little bit more accurately. Okay, so something like that, and then we've got, because it is symmetrical, we got the same shape happening on the left side. So something like that. So there's our basic parabola graph. Now what I'm going to show you is, if we put some changes to that graph, what is it going to do? And I'm talking about changes like this. Suppose I wanted to graph something that was y equals, and we'll just take x squared. Actually, we don't need the brackets there. We'll just call that x squared, and we'll put in plus 1. Now, what is that going to do to my basic parabola? Well, I could use a table of values to identify it, but I'm just going to go ahead and tell you what the graph will look like. It's basically going to be the same graph shape that we had before, but we're going to shift the whole thing up 1 unit. So it's kind of like the whole graph gets pushed up. So the vertex is no longer at 0, 0, but it's now at 0, 1. And then if you think 1 to the right goes up 1, and 1 to the left goes up 1, 2 to the right would go up 4. And I'm talking about from relative to the vertex. So up 1, 1 to here, 2, 3, and 4. So kind of up here-ish. And so this is what the graph would look like. Something like that. Now this graph, you'll notice that when we put the plus 1 at the end, it pushed the graph up. And that's exactly what's going to happen. If you put a number at the end, let's say you had something like y equals x squared minus 2. All that the number at the end is going to do is pull your graph vertically up or down. In this case, I can see, oh, it's minus 2. It's going to pull my graph down 2 units. So I draw a little guideline in here, and I go, that's where my new vertex is. And it's a congruent graph, so it's going to have exactly the same shape as if I just had y equals x squared. So I know it's 0, 0, and I'm treating this point here, the vertex, as kind of 0, 0. Then I know the shape of the graph is 1 to the right and up 1, 2 to the right and up 4. So that really gives me exactly the shape of this parabola. Okay? So the same thing due to symmetry is going to happen on the other side. So got the same sort of thing happening over here. Okay? So that's what the number at the end does. So when we're talking about standard form, we're saying this number here moves the graph up and down. That's what this guy does. Now, to move your graph left and right, it is different. It is if you put a change in where the x squared is. So normally we have x squared here. What I'm going to do is cram a little change in right next to it. Say I had x minus 1. Now, if you recall with absolute values, to find a vertex, we simply asked ourselves, when does this become 0? And so the same thing is happening here. This is going to become 0 when x is 1. And that tells us the coordinate, the x coordinate of the vertex. And in this particular equation, the y coordinate would be just 0. So what we have happening here is this graph has shifted the vertex over to the point 1, 0. So it's shifting 1 to the right. Now, if I treat this point here like my vertex, there's no other change to my parabola, so I know it's fundamentally going to be 1 to the right, up 1, 1 to the left, and up 1, 2 to the right, and then up 4. So squeeze that in here. So 1, 2, 3, 4. So kind of up here somewhere. And then same thing on the left side, I would be 2 to the left of the vertex and up 4. And so there's my parabola graph, something like this. Goes speeding right to that point. Okay? And so you can see what's happened is it's shifting the graph either to the right or the left. Now, if we carry on here, what if I have both of those things happening? So let's say I had an example where I had x plus 2 squared, and I went minus 3. Well, I think the key to the whole thing is to locate the vertex. We know the x-coordinate is whatever makes the stuff in brackets here become 0. So that's going to be negative 2. And then if I plug negative 2 into this, well, I'm going to get negative 2 plus 2, and that's 0. 0 squared minus 3. So my y-coordinate is minus 3. So this is a parabola that is shifting 2 to the left and then down 3. So this is kind of the new location of the vertex, is right down here. Now that's the new location of the vertex, but other than that, there is no other change to our standard parabola. And by that I mean it would still be 1 to the right and up 1, 2 to the right and up 4, and then the same thing happening on the left side. So 1 to the left, up 1, 2 to the left, and up 4. So there's our basic parabola graph. Okay. All right, there is one more change that I'm going to talk about, and that's where I'm going to stop here. And that is, what if you put in a number in front of the x squared? So you get something like maybe a 1/2 x squared. The number is not crammed in next to the x, and it's not tacked on at the end, but it's put right in front. In other words, I got some number which I believe I called a in the original writing of standard form. What effect does that have? And with this, basically you have to use a table of values to get an idea. If you go, say, 2 to the left, 1 to the left, 0, and then 1 and 2, it'll give you a pretty good idea what the shape of the graph is. If you plug negative 2 in and it's squared, that'll be 4. Half of 4 is 2. If you put in the negative 1 and square it, you'll get 1/2. Put in the 0, turn the whole thing to 0, and then again 1/2 and 2. I'm just going to graph it right over here, show you what the picture would look like. So you would have, instead of going 2 to the left and up 4, which is what we did in our original, we're only going up 2. So it's kind of vertically not going as high as it used to. If you go 1 to the left, you're only going up 1/2. And we used to go up all the way to 1. Still got 0, 0 for the vertex, and then we got 1 up 1/2 and 2 up 2. So there's our parabola. What we have here is a bit of a wider parabola. What we say here is that it is vertically compressed, because you take all your vertical distances and you kind of squish them into half as much. And that's, I think, where I'm going to stop with this first introduction to graphing quadratic equations using standard form.